All right, so the next unit for this class is actually chapters 13 through 16. So today I'm going to go through chapter 13, go through the notes, and go through some of the examples on Math Excel. This unit that we're doing, that we're starting today, is basically a probability unit. Some of those basic rules of probability that you learned when you were younger are going to come back in this unit. And today we want to talk about the fundamental counting principle and combinations. And the fundamental counting principle is something that you've learned before. You may remember doing problems like this when you were younger, where you have so many different choices of entrees and salads and drinks and desserts, and they want to know how many different combinations of dinners are there. And you might remember that the way we would solve problems like that is we would simply multiply the different number of entrees times the different number of salads times the different number of drinks times the different number of desserts. And whatever the answer was, in this case, 1,152, that was the number of different combinations of dinners. So that's kind of your basic type of fundamental counting principles, finding different numbers um, of combinations. Here's another example. License plates have three numbers followed by three letters. How many combinations of license plates are possible if digits and letters can be repeated? Um, and we, of course, know that we have 10 choices for each digits, and we have 26 choices. There are 26 letters in the alphabet, so 26 choices for each letter. So this would be, you would have 10 choices for the first number, 10 choices for the second number, 10 choices for the third number, 26 for the first letter, so on and so forth, and you would just multiply those out. And you can see here that there are over 17 million different combinations of license plates. What if I change that up? What if digits and letters cannot be repeated? Well, that changes things a little bit. Okay. If they can't be repeated, then that means for the three numbers, I could have 10 choices for the first number. But once I pick that first number, I can't use it again. So that leaves me with 9 choices for the second and 8 for the third. And similar thing happens for the letters. Okay. I have 26 choices for the first letter, 25 for the second, 24 for the third. So that's how it changes, and I would end up multiplying that all out. And you can see if I can't repeat digits and letters, that brings my number of combinations down to 11 million. So the fundamental counting principle is when you simply multiply the number of different choices you have, and that gives you the total number of combinations possible. Something to go along with this is something called a factorial. The factorial is the kind of the mathematical symbol for an exclamation point. Does not mean shout the number loudly. This reads n factorial, and what it means is it's the product of all the whole numbers from 1 to n. Okay? So that's what that means. So an example would be 5 factorial would be 1 times 2 times 3 times 4 times 5. Okay. 3 factorial would be 1 times 2 times 3. Okay. 50 factorial will be 1 times 2 times 3 times 4 times 5, all the way up to 50. Okay. 100 factorial will be 1 times 2 times 3 times 4 times 5 times 6, all the way up to 100. Okay. So you will see factorials a little bit in in this unit here. Now kind of to the crux of this unit, and that these are combinations. Okay. So this is kind of the textbook definition of a combination. It's the number of ways a set of objects can be selected without regard to the order that they are selected. So an example would be selecting 3 students at random from a class of 20. So if I had 20 students in a class and I put all their names in a hat and I wanted to select 3 at random, a combination would be the number of ways I could select 3 students from that group of 20 if the order I chose those 3 students in did not matter. Okay, so if I put those 20 names in a hat and I just select 3 at random, the combinations would be how many different ways can I select 3 students from the group of 20 if the order I choose those 3 in does not matter. Okay. And the way we calculate combinations is by using StatCrunch. So I put an example here to show you how it works. Okay, this is what you do on StatCrunch. You go to data, you go to compute, and you go to expression, and you type this part in right here. COMB, which is short for combination, and then in parentheses you put the sample size, comma, the number of items you're choosing. So how does that work in action? Okay, so let's go back to the example I used on the last slide. Excuse me. How many different ways can I select 3 students from a class of 20 total? So when you go to data and compute and expression, this is what comes up. Okay, and notice I typed in COMB for combination, parentheses, and then in the parentheses I put 20, which is the sample size. That's the number of students in the class, comma 3, the number of people I'm choosing. So COMB, which stands for combination, and then in parentheses right next to it, you put the sample size. In this case, the sample size is the total number of students, comma, the number of items, or in this case, the number of people you're choosing, which is 3. So when I did that, that's what came up. And for some reason, it's being black. There we are. All right, that's what came up. So this tells me that there are 1,140 different ways to select 3 students from a class of 20 total. So if I were to put 20 names in a hat and select 3, there'd be 1,140 different ways I could select those 3 names. That's what that is telling me. Okay. Here's another example. This is similar to one that you'll see on your Math Excel assignment. So let's take a look at this. There is a shelf containing 15 DVDs. Out of the 15 movies, 4 are comedies, 8 are dramas, and 3 are animated features. Find the number of ways to choose 6 DVDs regardless of genre. All right, the key in this case is regardless of genre. Regardless of genre. So there are 15 DVDs total, and I want to choose 6. So when I go to StatCrunch, I want to do that. Okay. There are 15 DVDs total, and I don't care about the genres. Okay. And I want to choose 6 random from them. 6 at random. So 15, 6. And you can see if I do that in StatCrunch, I get an answer of 5, 5,005. Okay, so that tells me that if I don't care about the genre, there are 5,005 different ways I can select 6 DVDs from a group of 15. Now, what if I do care about the genre? In this case, find the number of ways I can choose 2 of each category. Okay, that means 2 comedies, 2 dramas, and 2 animated movies. Well, this kind of changes things a little bit because now I have to look at each possibility. I have to look at 2 comedies, 2 dramas, and 2 animated. Okay, so let's look at the comedies first. We know that there are 4 comedies total. I want to choose 2 of them. So when I do that combination thing, okay, data, expression, when I do that on StatCrunch, I'm going to do this, okay, because there are 4 comedies and I want 2 of them. And notice I get an answer of 6. And I'm going to do the same thing for dramas. This time, there are 8 dramas, and I want 2 of them. So when I do that thing in StatCrunch, I'm going to do that because there are 8 dramas, and I want 2 of them. And then I'll finish it off with animated. Okay, there are 3 animated movies total, and I want to choose 2 of them, and I get that. Okay. And what the fundamental counter principle says, there are 6 ways. The answer for comedies is 6. The answer for dramas is 28. And the answer for animated is 3. Well, the way I find the overall answer is by simply multiplying the 3 individual answers together. So 6 times 28 times 3, there are 504 different ways to choose 2 of each category. Okay? So you see when it doesn't, let me go back here, when the genre doesn't matter, there are 5,005 different ways. But when I restrict it to 2 of each category, it brings me down to 504 different ways, which changes things a little bit. Okay? That is it for the PowerPoint. What I want to do now, and I'm going to do the same thing that I did in the last unit, and instead of having one assignment per chapter, I'm going to have one long assignment for chapters 13 through 16. So on Math Excel, there is a chapter 13, 14, 15, 16 assignment. And what I want to do is I want to go over the the questions on that assignment that have to do with chapter 13, which in this case are only the first 2 questions. So number 1 and number 2 on this assignment actually have to do with chapter 13. So let's look at number 1 here. I'm going to go over the first 2. Your literature class will read 2 novels this year chosen by class vote from a list of 7 possible books offered by the teacher. How many different choices of books could the class make? So this is just straight up going into StatCrunch here. So remember, for StatCrunch to find combinations, we're going to go to Data, Compute, and Expression. Again, that's Data, Compute, and Expression. And I'm going to type in COMB. And let's go back to the question for a second. There are 7 total books, and we're going to choose 2. So I'm going to go 7, 2. So 7 total books, 2 that I'm choosing. And I compute that, and let's see. I get an answer of 21. So the number of different choices of books the class could choose is 21. Okay. All right. As a check against possible accounting errors, each day a building supplies company audits 5 recently active accounts. Yesterday, they made they made sales to 17 retail customers and 10 contractors. How many ways are there to select the 3 retail accounts and 2 contractor accounts? Right. This is very similar to that question from the PowerPoint about choosing 2 comedies, 2 dramas, 2 um, animated. Instead of doing that, we're now choosing 3 retails and 2 contractors, which means that we have to basically do this thing in StackCrunch twice. We have to figure out the retail and we have to figure out the contractor. So for retail accounts, there are 17 total retail accounts, and I want to choose 3 of them. So let me get rid of this. So when I go to StackCrunch, again, I'm going to go Data, Compute Expression. Now I'm going to do COMB. Again, I'm going to do 17, 3. Okay, why that? Because there are 17 total retail accounts, and I want to choose 3 of them. Okay, so notice that answer is 680. Okay, and I'm going to do the same thing for the contractor accounts. So this time there are 10 contractor accounts, and I want to choose 2 of them. So once again, Data, Compute Expression, and I'm going to do COMB, and I'm going to do 10, 2. 10 total contractor accounts, and I want to choose 2 of them at random. Okay, so 10, 2. When I compute that, I get an answer of 45. Okay, so this is my answer for retailer. This is my answer for contractor. And the way I'm going to find the overall answer is to simply multiply those 2 together. So 680 times 45. So 680 times 45 is 30,600. So my overall answer is 30,600. And that is the answer to number 2. Okay, so those are the 2 questions in the assignment that have to do with number 13. Obviously, I'll do another video for 14, 15, and 16.